super happy fun time with Matt and Nathan. Oh, morning or afternoon class. Today, as you know, we're going to be making a video on properties of shapes in maths, such as triangles, or equilaterals, isosceles, scaling triangles, and like quadrilaterals and all that. So quadrilaterals such as squares, rectangles, rhombuses, kites, and trapeziums. We're not only going to do that, but we're going to be doing rectangles. I mean, we already said that. We're going to be doing hexagons and pentagons and like nonagons, septagons, decagons, octagons, and all that sort of stuff. So let's get started. Oh, all these triangles have appeared for me. This is an equilateral triangle where all the angles are 60 degrees and the rotational symmetry is of 3. Isosceles triangle, 2 equal sides and angles, as you can see. And it's a scaling triangle over here, where all sides and angles are different. Over here, this is an interesting one because right angle obviously has a right angle, but it also involves Pythagoras theorem where a squared plus b squared equals c squared. A, b, c. And the hypotenuse is the longer side of the triangle. Now class, moving on to quadrilaterals. We have a square here, where all sides are equal, all angles are equal, and the rotational symmetry is 4. 2 sets of parallel lines as well, as you can see up here. Now, the rhombus, all sides are equal, rotational symmetry of 2, and it has 2 sets of parallel lines, right there. Now, for a rectangle, opposite sides are equal. Pretty much it's like a square, but just that there are only 2 sides. And a kite, we have 2 sets of equal sides, 1 set of congruent angles, and the intersection of diagonals form 90 degrees angles. Now, for a parallelogram, we have 2 sets of parallel lines, opposite sides are parallel and congruent, and diagonals bisect each other. Oh wait, we also have trapezium. Now, diagonals bisect each other, 1 pair of parallel lines, and it's referred to as an regular quadrilateral. And that's about it, guys. Well, anyways, we have polygons here, and it looks like there's a pentagon. There's angle sum is 540 degrees, 5 congruent sides. The order of rotational symmetry is 5. And a hexagon is angle sum of 720, and the 3 sets of parallel lines. Order of rotational symmetry equals 6, and there's 6 lines of symmetry. Now, the heptagon. Sorry, like the heptagon, there's an angle sum of 900 degrees, and the order of rotational symmetry is 7. Now, there's 7 congruent sides, and sides meet at an angle of 3.1. Wait, no, that's pi. Sorry, pi. I just love pi. The sides meet at an angle of 128.571428.6 degrees. Yeah, I'm right. And the octagon has 8 congruent sides, and has an angle sum of 1080 degrees. They have 4 sets of parallel lines and has 8 sets of rotational and reflective symmetry. Now, moving on to nonagon. We have a rotational symmetry of 9 and the angle sum is 1260 degrees. That's a big number. 9 congruent sides and yeah. Now, let's have a look at decagon, where there are 10 congruent sides and there's an angle sum of 1440 degrees. That's really big. And damn, rotational symmetry is 10, and there are 5 sets of parallel lines. That's it for polygons. Oh, and did I also forget to mention the circle? Pretend it's 2D and it's got 1 side. Well, to calculate the area of this, you will need something that I really love. Pi. 3.141902.
No, that's wrong! It's 3.141596.
Well, excuse me!
No!
I'm the maths teacher here. Disrespect for kids. Well, anyways, that concludes our properties of shapes. And yeah. Oh, that's the spears. Well, first of all, I would like to thank you guys for watching this video. We tried to make it as enjoyable as we could, I mean. Well, I really want to thank my group as well, because they contributed as equally as I did. Just because I was in the camera? Just because I was in the camera for the longest? Just because I was a teacher? No. Thank you guys for being in my group. These amazing people. And yeah.
Thank you for
Watching. Wait, why do you guys have balls? Ah! Oh, and also, did I forget to mention the circle? Well, pretend this is 2D and stuff, and like, pretend it's only got one side. Well, to find out the area of this, you will need something I really love. Pi. 3.14152902.
That's wrong. It's 3.141592.
Excuse me!
Ow!
But I am the math teacher here. Well, I guess that concludes it. Sorry for that. Well, this concludes. Popped up just for me. And this is an equilateral triangle where all the sides are equal and has a rotational symmetry of 3. The angle here is 60 degrees on all sides. This is an isosceles triangle where 2 equal sides and angles are equal. This is a scaling triangle where all sides are different and angles, as you can see.